Okay, pre-calculus, in this video we are going to look at example 2 for 9.3. So we are dealing with vector, the vector unit, and we are dealing with speed and direction. So an airplane is flying in the direction of 148. That's a true bearing, so we'll need to use that to get the direction angle with an airspeed of 875 kilometers per hour. Because of the wind, its ground speed is 800 kilometers per hour with a direction of 140. So the wind pushes it from this direction to this direction. And we are asked to find the direction and the speed for the wind. Now, if you'll recall, in one of my other videos, we looked at this mathematical relationship of our three vectors. We've got a resultant vector, an original course vector, and a force vector. So we are using that relationship to find the wind, okay, so the force. So that means I'm going to subtract V from both sides. So this is my original course right here, and this is my resultant course right here. So you have to keep everything straight, and then I'm finding the the direction and speed of the wind. Okay, so the very first thing we're going to do is we're going to use this information right here to find our original course. Okay, so our original course, and we're going to let that be V in our formula here. So I'm going to use the true bearing that starts north and goes 148 degrees in the clockwise position. So if this is 148, that means this is 90 for quadrant 1, and then plus another 58 degrees to give me a total of 148. So I need the direction angle. The direction angle starts here and goes all the way around this way to this vector. So that's 90 degrees, another 90 degrees, another 90 degrees, and 32 degrees, because this whole quadrant is 90 degrees. So if I take, okay, pay attention here, if I take 3 quadrants, that's 270 degrees plus 32, that means my direction angle is 302. So for V, I've got the speed, 875 times, oops, God, get it together, Miss Griggs, times the cosine of the direction angle, that's why you need your direction angle. All right, so the vector of the original course, when you type all of this into your calculator, is going to give you 463.7 and negative 742. So we're going to need that in this formula right here. Sorry, right here. All right, the next thing we're going to do, and I'm going to switch colors here, we are going to find R. Okay, so R is going to be the resultant course after the wind acts on it. All right, so again, we are going to need to find our direction angle because we have to have direction angle in our velocity vector. All right, so we have 800 kilometers per hour at 140. Okay, so the bearing now becomes 140. So again, this is 90 degrees, this is 50 degrees, I'm sorry. And then that means this is 40 degrees. So again, changing color, my direction angle starts here, goes counterclockwise to the vector. So 3 quadrants, 270, plus the 40. And so that is 310 degrees. So my resultant is going to be 800 kilometers per hour times the cosine of my direction angle, 310, and then again we type this into our calculator and we arrive at 514.2, negative 612.8. All right, so now what we need to do is use this mathematical relationship to find the velocity vector for the wind. Okay, let's pick another color. All right, so that means that W is going to equal R minus V. All right, so what we need to do then is we need to take R, 514.2, and negative 612.8 minus V, which is 463.7 and negative 742. Awesome. All right, so remember, keep the horizontal components together and the vertical components together. So 514.2 minus 463.7 gives me 50.5, and negative 612.8, notice what happens here. The negative gets distributed, so plus 742 gives me 129.2. Okay, now we're going to use this to get our speed and direction. All right, so the speed is easy. So the speed of W is just the square root of the horizontal component squared plus the vertical component squared, and that is going to give me 138.7 kilometers per hour. Awesome. Now we have to figure out the direction of the wind. So I've got to draw this. So using this right here, I've got positive 50.5, positive 129.2. There's theta. So I'm going to use tangent theta equals opposite over adjacent. So tangent inverse gives me theta equal to 68.7 degrees. That is not the direction. This is just my reference angle. So this is 68.7 degrees. Now what we need to do is figure out the direction. So this is north. If I subtract this from 90, I get this angle right here, and that's going to be 21.3, and this is east, so my direction could be north 21.3 degrees east. You can write it that way, or you can write it as a true bearing, which would just be then 21.3 degrees, because a true bearing starts north and heads clockwise. So either one is correct. It doesn't matter. Easy peasy lemon squeezy.